Q&A pod. This is a go back to ellipses, and some of y'all aren't at ellipses yet, but see if you can remember from last week. What is important about the denominator in ellipses? So hyperbolas, it's which denominator is listed first. What's important about ellipses? I had you write it at the top of your paper last week. What's important about what do you got to look at for ellipses? There you go, Morgan. That's exactly right. Good, Amanda. Good. Everybody type something. Even if you don't know, type something in the chat pod so I know that you're responding and that you're here and paying attention. Okay? And those of you who are not sure, it's okay. It's all right. That's right. You remember. Good. Good, Tiffany. That's right. That's right. Go back to your notes. That's okay. Sometimes, Donovan, that's true, and sometimes it's not. It depends on the denominator, right? And it's okay to not know. A couple of you said you didn't know. All right, so I only had 1, 2, 3, 4, 5, 6 people type in the chat in the Q&A pod, and there are 10 people here. So you see, so there's 4 people that didn't bother to type anything, which means they didn't pay attention to the question. So that's not good. All right, but for those of you who did, I appreciate it, and that will reflect in your participation grade. All right, so let's talk about hyperbolas. At the top of your paper, write which denominator is first. Totally different than ellipses. It's all about which denominator is first. So when you look at the equation, you're going to see the difference. What's the other one called? I can't remember. Transverse, and I never could remember the other one. Hold on a second. What's the vocabulary right there? Conjugate. Okay, so you have a transverse axis and a conjugate axis. You have vertices, right? So the blue dots are the vertices, and that's at the end of the transverse axis. And the difference with these are they have asymptotes. So you've got asymptotes involved. The focus point is on the inside. On the inside. That's cute. Okay, so let me show you why I like hyperbolas real quick. Because, oh, that's not what I want to do. New. There we go. Don't save. Hold on a second. I know you can't see it yet. I like hyperbolas, and I haven't showed you the equation. Oh, goodness gracious. I can't seem to get my clicker to click the right thing. All right. When you take an ellipse and you cut the ellipse on the major axis, right down the major axis, and if this is a vertice and this is a vertice, if you take that ellipse and you shoot it away from the major axis, it creates a hyperbola. And I wish I had my video cam with me so I could, oh wait, maybe I do. Hold on. Maybe I do. Hold on a second. Let's see if I can get it to work. Got my little computer here. It's got one. Maybe I can, because I like to, I think it's a really cool kind of a visual, if I can make it work. All right, well, let's see if that'll work. Hold on. Can y'all see that? Here's me in the hotel. I'm going to do some testing tomorrow. So if you have your ellipse right here, and you cut it in half, and you shoot it out like this, that makes the ellipse. Or if it's like this, and you cut it in half, oh, wait, here. I got it. Oh, shooters. Hold on. Where did it go? Oh, now it went away. Oh, I can't make it work. Just too many things. You saw the video? Yeah, I didn't click the right, but y'all want me to try again? All right, hold on a second. It really wasn't that great of a visual. It was just me, you know, showing you something. All right, hold on a second. Let me try again. All right. There we go. All right, so if you take your ellipse right here, all right, pretend like my fingers are my lips, and you cut the ellipse in Going this way, it's going to cut in half and it's going to flip out. Ooh, there we go. Flip out and make your hyperbola. So an ellipse and a hyperbola are very similar. There's only one little thing different in the equations. If this is the ellipse, the hyperbola goes out like this. All right, so I'm going to stop doing that because I think it'll freeze my room up. All right, let's hide that. Let's let Earl in. Hey, Earl, you might want to watch the doesn't do the same thing, does it? It just doesn't do the same thing. So what happens when you look at your equation, let me show you. Oh, you're back. Okay, cool. Hyperbola, it is really a great tool. So make sure you do that. And that's not the equation, but it's coming. Here you go. All right, so here's the equation of your hyperbola. Okay. Or y minus k squared over a squared minus x minus h squared over b squared equals 1. Now notice, with ellipses, a was always under the bigger axes. Here, a is always first. It opens on the x-axis. If the y is first, it opens on the y-axis. Okay, it's all about the graph, the equation, and how that relates to the graph. So I'm going to say that again. If the a is bigger, no, first, it's all about what's first. It doesn't matter if it's bigger or smaller. The y is first, the hyperbola opens. Hyperbolas are a subtraction on the formula. It's okay, Taylor. You just want to watch the beginning of the recording. And the Pythagorean identity is a squared plus b squared equals c squared. Everybody in the chat pod or in the Q&A pod, type what the Pythagorean identity for ellipses is. If you're not right, I won't say your name. Everybody real quick. You don't remember. It's okay if you don't remember. Give me something so I know you listened. All right, there you go. That is right, Amanda. That is right. So ellipses and hyperbolas are similar. Similar? It's okay. It's okay if you don't remember. It's all right. But the fact that you put that you don't remember, I know you're paying attention. The idea right now for the Q&A pod is I'm not really paying attention who's not answering, but when I'm going to do attendance, I'm going to save the Q&A pod. If you did so for ellipses, what is the Pythagorean relationship for an ellipse? For sure. Okay? And that's okay. So I'm going to tell you. In an ellipse, the Pythagorean relationship is a squared minus b squared. If you're having sound issues, oh, it's really frustrating, girl. I know. I was 15 minutes late in my first session today because I was having all sorts of issues, so I totally understand that. Of course, he can't hear me. Problem is, when you're doing the problems, it's not going to be that big a deal because you're going to do all ellipses. You're going to do all whatever you're working on. But when, oh, that's not going to work. When you go to do the test or a quiz where it's all mixed up, you got to know the difference. For ellipses, it's x minus h 1. That's an ellipse. All right. For a hyperbola, it's x minus h squared minus y minus k squared. All right, you see the difference? That's right. Ellipses are plus. This one, A is bigger, so this ellipse is going to be this direction because it's under the x. This hyperbola, the first term is x, so it's going to open like this. All right, the other way it's going to be would be x minus h squared over b squared down because the bigger denominator is under the y. The hyperbola one that other. And this ellipse, the y is first, so it goes like this. Varieties of those formulas. Yeah, and that's the next thing I was going to talk about, Amanda, is the difference in the Pythagorean identity. That's right. For ellipses, it's always a squared minus so it's a lot to remember, and it's important to get that all straight. Okay, and if you can think, to me, if I can think about it visually, it just makes it so much more straightforward. Hyperbolas are always subtraction, and it's all about what's first. This one opens on the y-axis, this one opens on the x. And it's whatever's bigger. The bigger denominator tells you which axis the longer the major axis is on. And then this one is always the minus. Those are the things that I did in green are the important pieces to remember. Okay? Give me a green check when you're ready to do some problems with this. And you've got that kind of written down. You've written down about that information written down on your notes. So I'll give you a minute to do that, because sometimes I know I can't see you, so I don't know that somebody's still writing. A is always bigger denominator in ellipses. In ellipses. The bottom equation is your Pythagorean relation. Problem is, or what they gave you. Okay. Hyperbola, yeah, it does. Hyperbola. That's my attempt at hyperbola with cursive and a mouse and ugly. And some of y'all have been sending me your work that you're doing that I've asked you to. And Billy and Taylor. Just let me know that you finished up your notes and you're ready to go to the next thing. Okay. Waiting on Javante. the live lesson because we only have an hour a week. That's not very much. And I know you have live lesson with lots of students. Billy, Javante, are y'all ready? Okay, cool. We're ready to roll. Good, good, good. And it's okay if you weren't. I just need to know that you weren't. You're full screen. Going to pick some in the book as I went because I wanted. All right, so let me do that. Let me open to the right page here. All right, let's do one where we have that, all the pieces and parts and that. I just copy and pasted that picture out of page 646, so you can look at that in the book. Let's do one that we're actually Number 19 says 81y squared minus 9x squared equals 729. K squared, remember the y and the k go together, x minus h squared, and we know we needed it to equal 1, and we need if I divide one term by 729, then I have to divide all the terms by 729. So 729, excuse me, 81 times, so this ends up being x squared over 81 and equals 1. Now I'm in the format that I know a lot about it. So what's my center? That's the easiest one to find. I don't even need to know that. Oh, y'all are typing and my little chat pod's not scrolled down. I might have... Okay, yes, the origin, that's right. And to be honest, in this section, this first section you do hyperbolas, they're all going to be from the origin. The couple and the x go together always. That's something that I, as a student, I always messed up. So let's kind of sketch this. Graph paper is your friend. I don't have any graph paper, so I got to eyeball it. I have graph paper at home, but I'm not at home. Squared. So from the y-axis, I'm going to go up 3 units and down 3 units. And so that's going to give me a point that I'm going to need. And from the x-axis, I'm going to go to the left 9 units. I'll call that 9. And I'm going to go to this was an ellipse, we would connect our dots, and there we go. Our foci would be here and here, but it's not an ellipse, so we know our focus point's going to be here and here, and we know because y is, oh wait, no, it's not going to be there and there. That is incorrect. I know this thing opens this way. Even though it's not bigger, it doesn't matter. Because y is first, I know my general shape of this looks like that. So my focus points is on the inside here and here. But that's okay, because it's with hyperbolas, it's all about which one is first, not which one is bigger. So this axis is actually bigger. I never can remember the name of that other axis. Conjugate, yeah. The transverse is the one that connects the vertices. So this, because if this was an ellipse, we'd connect the dots, but it's not. So what we're going to do is we're going to take the vertices and the endpoints of that conjugate axis. Are the asymptotes. So that tells you how big the graph opens up. So I'm going to fix that to be more reflective of what's really happening. Like that. It's not really called that, but you're not really, because think about the directrix in a parabola. And the conjugate axis is kind of a line. Maybe, yeah, you might. But see, the thing you got to be careful with, the C is not the same. In this picture, we're going to find that. Oh, let's not use red. This distance from this focus point to here is C. From the center to our focus point, box is always going to work. Isn't that cool? Oh, we were just going to graph it and find the focus points. Okay, so there was our little graph, but now we got to find the focus points. The box will always work. Yep. So if you're on graph paper and you had to find the slope of I kind of know what it is, but not really. I know, it's kind of dorky, isn't it, Morgan? I know, but I do. And here's why I like it, though, because as a student, it was really hard, and I never thought I could do it. And I always felt like everything was so hard. And so I could explain it in a way that the teachers couldn't, because the teachers just could. They didn't, they just made so much sense. And to me, I had to, since the 80s. Yeah. I know. Okay, so let's finish this because we got to find the order pairs of the focus points. So we know that the A is first. The 81 equals, that should be a C squared, and 9 and 81 would be 90. Yep. So the square root of simplify it. I was being a little lazy there. And 0, 3 square roots of 10. And simplifying those a little bit. All right, so the problem was graph and find the focus points and the vertices. So we can just look at the picture and see that it is 0, what was that, 4, 3, and 0, -3. And there's our vertex. Ta-da! Now, hyperbolas are supposed to be really, really hard, but by the time you get to hyperbolas, what makes it... No, they don't have covertices. They have endpoints of the conjugate axis, though. That's a really good question. Yeah. But that's not part of the vocabulary for hyperbolas. Things to draw the graph. Right? So even though this is an important ordered pair to get this box, to get... Yep. All right. Y'all ready for another sample? Woohoo! The endpoints of the conjugate axis. All right, everybody, real quickly, type in an ordered pair of the vertices. Just one of them. Real quickly. Type in the Q&A pod. Ordered pair of the vertices. It's on the whiteboard right there in front of you. The vertice right here. Just type one of those in the Q&A pod. Yeah. There you go. Yay. Morgan, get both of them, both parts. Okay, let's do another problem. Let's do one where they give us the pieces and parts, and we have to write the equation. So that'll be kind of the other way around. All right, let's do this number 28. File, new, don't save. Javante. That's not what I asked for. You gotta pay attention. So vertices is plus or minus 2, 0. 0. Ugh, plus or minus 2, 0. Okay, you might want to watch the end, Morgan, so you can get the rest of this last example in. All right, so I'm going to, my square root of 5, 0 is my focus, so we'll call that right here. And the and my vertices are at 2, 0. Hold on a second. Yeah, so my vertices are going to be here. They're really close together. Opens. Wait, that doesn't make sense. Oh, the focus square root of 5 is 2 point something, so our focus is actually here. Yeah, yeah, because square root of 5 is 2.3, 2.2, so it's actually a little longer than 2. I was thinking graph. I know this thing's going to open this way. So what's going first in my equation, a x squared or a y squared? I can tell that by the picture. Because remember, it's all about what's first. That's right. And it's always going to be equal to 1. Now we got to figure out what goes in the denominators. All right. We know right now what goes in this denominator. It's the distance from here to the vertex. All right. So it's going to be 2 squared. 2 squared. Now, I don't know this one, right? I don't know the one that's going to go out here at the endpoints of the conjugate, but I know the distance of C. The distance of C is going to be dandy Pythagorean identity. And because it's in a hyperbola, it's a squared plus b squared equals c squared. All right, so we've got 4. Let's square that. So we get 4 plus b squared equals 5. So now we can subtract. I'm going to kind of go back up here. Subtract 4 to both sides. So if I were going to graph it, I would have my little conjugate axis. I would have my little box, right? I would drop in my asymptotes. It's going to be a lot easier to see what's happening. But so they only gave me 2 little pieces. They did a lot easier. A lot easier. All right, questions. I know y'all are writing all that down, so I'm going to let you write for just a second. It does. And I wouldn't always say to. Long term, you're going to be a happier camper because you can see the orientation of how everything's related. And like I started that backwards, and I knew that that was wrong, so that made most things. There you go. How about this? Graphs make conic sections easier. Yep, absolutely. Is going to be similar. Drawing a graph helps. The distance from the center to the focus is always c. So it doesn't. If you're in a parabola and you're working on the parabolas, guess what? The distance from the center is c. So a lot of this stuff is over and over and over the same thing. Same. Every little part and piece is a smidgy different than the other. All right, give me a red X if you need me to wait and not move to the next problem. So plus or minus 2, 0. Oh, now it's not any better. There we go. Okay. Where we have to get it in the form. Oh, wait, do we have to do that any with these? No, we don't. Okay. In this lesson 10, you don't have any completing the square problems that you have to do. Okay. In lesson 10, information about all the conics, and now they're going to translate. They're going to move things around. So let me show you what ends up happening. And there's tons of formulas. Like, for instance, I want to pick a hyperbola because that's what we're working on right this moment. Now, do you remember what the coefficients are going to be if it's a hyperbola? Does anybody remember? All right, y squared minus x squared the conic section. And in this section, they're not going to tell you which one it is. They're just going to say, graph the conic and give all the pieces and parts and all the information you can give about it. So the first thing we have to do is say, ooh, which kind of conic is this? This has different, this is a positive y squared and a negative x squared. I know right away it's a hyperbola. Okay. If the A and the B are the same, then it's a circle. Okay. If the A and the B are not the same sign, ellipse. And if the A equals 0 or the B equals 0, it's a parabola. That's that's a scribbly mess. Parabola, parabola. Okay, that's just a review of something we talked about a couple weeks ago. So I know this thing is a hyperbola because this was a positive and this one's a negative. And my signs, because it's easy to make a mistake. Okay, and I'm always going to end up with a plus here at first. All right, so now I want to write this as something squared. I have to complete the square. What's my special happy lovely number that's going to go right here? And I know more than one person knows. Let's just see who types faster. Some of y'all are fast typers. If it was texting, there would be no competition. It would be crazy how fast y'all do it. None of that popped through. Why am I not seeing the text stuff in the chat pod? All right, we got some conflicting information. Let's kind of take a, let's see, -2, -4, maybe -2. Does anybody remember what the process is that we're using to figure this out? I'm not sure. That's okay. All right, so remember what we're going to do is we're going to take the B coefficient, we're going to half it, and we're going to square. Lines of what you were thinking. All right, so you take the middle coefficient, you half it, You square it. That's our special, lovely, wonderful number that makes this a perfect square trinomial. But if you add 4 to this side, you got to add 4 to that side. Okay. Now let's do the next thing. The next thing we'll do over here in green. Let's do in blue. When you square it again, I haven't factored it yet. But we're going to write this as a perfect square in just a second. Yes. But I'm going to do this one first, then we'll do them together at the same time. Sixes do look like B's. But they look like that even when I write on paper, so I can't really blame it on the mouse or anything. All right, so here's the thing we can do again. We just jumped right to what we needed to do because this had a 1 coefficient. We don't have a 1 coefficient here. We take our -6, we're going to half it, we're going to square it. So that gives us -3 squared, and that is 9. So our special, wonderful, lovely number to complete the square here is +9. But we really don't. So if we subtract 9 here, we have to subtract 9 here. Now that was a big leap in logic, and I did a lot of stuff in a very fast, quick fashion. So let me say it again while y'all write it down. I have to have a positive 1 coefficient. So I chose to factor out a term, -6, and I halved it, got -3, squared it, and got 9, because -3 times -3 is 9. So I'm going to add 9 here, but what I really did was added 9 times -1. And 9 times -1 means subtracting 9, so then I subtracted 9 over here. Now I'm ready to write as a perfect square trinomial. So we've got y minus 2 squared on that term, and this term is it's not a it is a hyperbola. It's just a weird hyperbola. Okay. Did we lose some students? I think we might have. Oh, I forgot to do attendance. I'll have to look at that in a minute. Oh, actually, I can do it right now. Let me do it right now. Where's my little sheet? I'll put and it's still here. Where are you, Jameson? I don't see you on my list. Oh, there you are. Okay. Here you are. All right, so we've got Alec. Now, no, I am going to be looking over my question and answer pod answers. So recording. Ambrose, Taylor, Camille. I know. Donovan. Gotcha. Shoemaker. Gabriel. And I'd like to do the attendance at the beginning when we first started doing it. That's okay, because sometimes everybody was not coming to the and I gotta say, almost y'all are doing really, as a class, I'm very pleased. Got a couple people that are really working hard, and the grade's not quite where we want it, but for the most part, I've got very few students that aren't doing anything in this class, which I really appreciate. And I got Tiffany. Okay. I didn't have a question, Taylor. I was just doing attendance. Let's see. I think there's a question in the Q&A pod here. Is there a page? Six, it puts them all together. Okay, so the lesson 2, 3, 4, they're all individual, and then a lesson 6, it pops it all together. Yep, that's a good question. Okay, let's do, so did we finish that? Hold on a minute. No, I've gotten distracted. Yeah, oh, we didn't finish it. We just got it. So what's this denominator going to be? And what's this denominator? It's already equal to 1, so we don't have to do anything else. We're done with that part. But we got to have something here, and we got to have something here so that we can actually do the graph and figure out all the parts and pieces of this hyperbola. So all right, so our center is HK. Now, my guess is, wait, because there has to be a denominator. Think about the formula for hyperbolas. It is HK, and in this problem, what is HK? Type it in the Q&A pod. Let everybody have an opportunity, and I'll tell you if you're right, and I won't say your name if you're not right, so I don't want to embarrass anybody. I type it in the Q&A pod. Let's see. Numerator to denominator. Be careful. H goes with X. Be careful. It's important to kind of think. Remember, X minus H and Y minus K. HK is your center. Okay, HK. X minus H, Y minus K. Oh, y'all typed it. It's just not scrolling. Oh my gosh. I'm like, why are they not typing it? Nope. I have Amanda. Yes. Ambrose. Close. Right. And Billy, you're not the only one that's not there yet. So this is all like, I haven't even done it yet. Remember, it's Y minus H. X minus K. I am really sad that that few students got the center. Y minus H, X minus K. The X minus comes. Who got it? Wait. Let me go back. Amanda got it. And Amanda got it. I'm going to tell you what it is in just a second. I just let you think. Go, Amanda. You are fabulous. Everybody else is too. You just got to get it. No, don't quit. Don't quit. Think. The K is the one that's with the X. The H is the one that's with the Y. X minus. Oh, look, I drew it wrong. I'm sorry, y'all. I freaked y'all out. Look, that's wrong. X minus H. H goes with the X. H, the first part of the center, goes with the... I wrote that wrong. I'm sorry. I messed y'all up. X minus H, Y minus K. We are doing it wrong because I wrote it on there wrong. Duh. X and H go together. Here the H is 3. Here the K is 2. So your center is 3, 2. Mmm. Mmm. I know. Some people had some negatives or flipped around. I mean, a lot of y'all were really close. Yeah, a lot of y'all were really close. Right? Because remember, the X minus comes from the formula. That's from the formula. The H is a positive 3. The Y minus comes from the formula. The K is a positive 2. And what I would do as a student, I would always call it 2, 3. 100 times I got that problem wrong all the time. But the Y and the K go together. So if they're together with the Y, it's the second part. Remember, it's H, K. The Y goes with the second part of the center. The X goes with the first part of the center. Yep. Learn from my mistakes, young children, students. Don't do what I did. Don't make that mistake. There you go. Okay. So now we've got our center. We know that our A and our B equal 1. So, yeah, that's going to work. So A is 1, B is 1. So if we're going to graph this guy, we've got our center at 3, 2. Graph paper is going to be your friend. And underneath the Y is a 1, so we're going to go up 1, and we're going to go down 1. And underneath the X is a 1, so we're going to go to the left 1 and to the right 1. If this was an ellipse, we'd connect the dots and be done. But it's not an ellipse. So is this one going to open up and down or left and right? What do you think? Up and down, left or right? Remember, with hyperbolas, it's what's first. All right. It's what's first. The Y is first. So it's going to open on the Y-axis. There you go. There you go. All right. It's all about what's first. Since the Y is first, that tells me this graph opens up and down on the Y-axis. It's not going to be on the Y-axis, but it's going to be parallel to it. So it's going to look like this. Because the Y is first. It's all about what's first. If the X was first, then it would go left and right. So if the Y is first, it's always going to be up and down hyperbola. Okay, that means my focus point is going to be in here, and this focus point is going to be in there. Right? I know. It's a lot to remember. It's a lot to remember. It's very detailed. There's no way in the world you can do this if you don't practice. So if you're one of the students that's clicking through the lessons and going straight to the practice, straight to the graded assessment, you're not going to do yourself any favors. How did I get the dots around? Let me go back over that. That's a good question. I know that this is my center. So I look at the denominator under the Y. So this one has a 1, and they happen to be the same. They're not always that way. So I'm going to go up 1, and I'm going to go down 1. In this case, that gives me my ordered pairs of my vertices. Okay. Underneath the X, whatever that denominator is, that's how much I'm going to go left and right. I know. Oh my gosh, can you believe it? It's so fast. Okay. So our vertices here are 3, 3. And this one's going to be 3, 1. And that's why graph paper is nice, because you can actually see exactly where it's supposed to be. And to find the focus points, you're going to do a squared plus b squared equals c squared. So c squared is 2, or the square root of 2 is c. So that would be here and here. That gives you this distance is the square root of 2, and this distance is the square root of 2. No, this one's not centered at 0, 0 because I have a H and a K. I know, I got to close up the recording because I got kids waiting, piling in to come in for the next session. All right, so when you get to this, this is the one of the last sections. You're not here yet. All the ones that you're working on, those first 3 or 4 sections, are all going to be centered at 0, 0. This one's not, so I'm just kind of giving you a preview of what's to come. So take a deep breath. I know you're not going to have to do one like this just yet. Okay, so that's coming in that section 6. And we'll meet again in live lesson and do, I think I've got next week. Oh, actually, let me show you what's for next week real quick, and then we'll be done. Next week is, yeah, we're going to do a Q&A on conic sections. Okay, so we're going to do more conic sections. We're going to practice with whatever y'all need help with next week. All right, if you're watching the recording, this is what I need you to do. So we are all done. A lot to go. It's a lot to process. Practice. Make time to practice. If you don't practice, you're not going to get it. But if you practice, you can do it. You can do it. Just shoot me an email or a webmail if you have any questions, you need help with any of it. All right. See y'all soon. Bye. All right. All right. Bye, Atunu. All right. Hey, guys. Let me stop the recording from just a second ago. Hold on just a minute. Oh, wait. I got to do it on my other computer. Hold on just a minute.